Welcome all of you to Presidency Senior Secondary School online class. I think all of you are in good healthy condition. So I have already discussed in my last 3 classes about solution. That is, what is solution, binary, ternary and quaternary solution on the basis of number of components present. Also classification of solution, that is 9 different types of solution on the basis of physical state of solute and solvent. And finally, we have discussed 8 different units for expressing concentration of solution, and they are connecting numericals. So today's class I will mainly discuss solubility of solid in liquid, first part, and second part solubility of gas in liquid. So there are two parts, one solid in liquid and second is gas in liquid. Solid in liquid means say sugar in water, sodium chloride in water, potassium chloride in water, silver nitrate in water. So solid in liquid. And second part I will discuss solubility of gas in liquid, say carbon dioxide in water, sulfur dioxide in water, ammonia in water, oxygen in water, nitrogen in water. So this part is gas in liquid. So first part I will start solid in liquid. That is, solute is solid. It may be say KCl, NaCl, KNO3, CuSO4, etc. And liquid may be water or other solvent. So this is solid part and this is liquid part. Solid in liquid. Here solid is solute and liquid is solvent. So first of all, here an important term, solubility. What is solubility? Solubility means, in general, solubility means amount of solute required to saturate a specific amount of solvent. So what is solubility? Solubility means amount of solute required at a given temperature to saturate a given amount of or specific amount of solvent. So solubility of solid in liquid is defined as amount of solid or solute required to saturate 100 gram of water. So solubility of solid in liquid is defined as amount of solid that saturate So this is definition of solubility. So solubility means the amount of solid that saturate 100 gram of solvent at a given temperature. For example, if solubility of sodium chloride is 20 gram, it means that 20 gram of sodium chloride required to saturate 100 gram of water. If solubility of potassium chloride is 22, it means that 22 gram of potassium chloride required to saturate 100 gram of solvent or water. So what is solubility? Solubility is the amount of solid or solute required to saturate 100 gram of solvent at a given temperature. Now, solubility of solid in liquid depends on 4 factors. Number 1, nature of solute, that is solid, and solvent, that is liquid. Number 2, most important one, temperature, and less important one is pressure. So, solubility of solid in liquid depends on 4 factors. Nature of solute, that is solid, nature of solvent, that is liquid, temperature, most important factor, and also pressure. Now, first we consider nature of solute, that is solid, and nature of solvent, that is liquid. So in my last class I have discussed few minutes about nature of solid and nature of liquid. Here an important term is used, which is like dissolve like. Like dissolve like means if substance is ionic or polar, then it is soluble in polar solvent like water, and if substance is non-polar or covalent compound, then it is soluble in non-polar solvent like benzene, chloroform, carbon tetrachloride, etc. So this is basic principle for solute and solvent. Like dissolve like means polar solid or ionic solid dissolve in polar solvent, and non-polar or covalent solid dissolves in non-polar solvent. So first we consider first point. First point, that is nature of solute and nature of solvent. So here a basic principle is used, which is like dissolve like. Like dissolve like. What is like dissolve like? That is both solute and solvent are of similar kind. For example, there are two types. One is polar or ionic solute or solid dissolves in polar solvent. Polar solvent. So this is polar or ionic, so this is also polar or ionic. So like dissolve like. For example, say potassium chloride, sodium chloride. So these are ionic solids. These are ionic solids. So they dissolve in polar solvent like water. So this is ionic or polar, So dissolve in polar solvent like water. So this is like dissolve like. So this is one case. Both are polar or both are ionic. So this is one case. There is another case. Both are non-polar. Non-polar or covalent solid, solid or solute, dissolves in non-polar solvent. So here non-polar, this one also non-polar. So this is like, this one also like. So there are two like cases. One both are polar and second one both are non-polar. For example, say camphor, which is a non-polar covalent solid. It dissolves in benzene, which is also a non-polar solvent. So camphor, which is a non-polar covalent solid, soluble in non-polar solvent like benzene. So this is like dissolve like. So our first case, nature of solute and solvent. So here basic principle is like dissolve like. If solute is polar or ionic, then it is soluble in polar solvent. If solute is non-polar or covalent, then it is dissolved in non-polar solvent. So reverse is not possible. That is, polar or ionic solid is insoluble in non-polar solvent, or non-polar or covalent solid insoluble in water or polar solvent. So reverse is not possible. So this is our first point. Like dissolves like. If both solute and solvent are polar or ionic, then dissolution is possible. If both are non-polar or covalent, then also dissolution is possible, but reverse is not possible. So this is our first case. That is nature of solute and nature of solvent. So next we consider our second factors. First point, nature of solute and solvent. Second factor, which is most important, which is temperature. So next we consider temperature. Now in case of temperature, this is very important factor because temperature has a marked effect on solubility of solid in liquid. So this is most important factor because temperature plays an important role for solubility of solid in liquid. Now there is not a single line which can explain temperature effect. So on the basis of temperature effect, solids are classified into three types. So there are three types of solids on the basis of temperature effect. For some solids, whereas temperature increases, solubility also increases. For most of the solids, about 95% of solids, whereas temperature increases, solubility also increases. For some solids, as temperature increases, solubility decreases. And for very few numbers of solids, where as temperature increases, first solubility increases up to certain temperature, and beyond this temperature, as temperature increases, solubility decreases. So there are three kinds of solids on the basis of effect of temperature. Most of the solids, about 95% of solids, where as temperature increases, solubility also increases. For few numbers of solids, as temperature increases, solubility decreases. And for very few numbers of solid, there is a peculiar behavior. What is this behavior? First, solubility increases with increasing temperature up to certain extent, and beyond this temperature, solubility decreases on further rise of temperature. So first increase and then decrease, very few number of cases. So first we consider first type of solids. So what is first type of solids? As temperature increases, solubility also increases. As temperature increases, solubility also increases. So if we plot a graph between temperature and solubility, so most of the cases where as temperature increases, solubility also increases. So this is for about 95% of solids. So why temperature increases, solubility also increases? This is because dissolution process is endothermic. Dissolution process is endothermic. What is endothermic process? Solute plus solvent solution, and process is positive, means endothermic. What is endothermic? For example, if we treat sodium chloride in water, sodium chloride is solute, water is solvent, then aqueous solution of sodium chloride is formed. Aqueous solution of sodium chloride is formed, and in this process temperature is dropped. That is, there is decreasing temperature or there is cooling effect. So this is cooling effect, that is process is endothermic. So for those solids where dissolution process is endothermic, that is enthalpy change is positive, for such solids as temperature increases, solubility also increases. So first type of solid where as temperature increases, solubility also increases. This is because for such type of solids the dissolution process is endothermic. That is, when solute dissolve in solvent, that is solution is formed, there is a fall of temperature, that is del H is positive or there is cooling effect. So process is endothermic. So this is because according to Le-Chatelier principle, as temperature increases, reaction move in the forward direction or endothermic direction. So there is more and more solute dissolves in water. So solubility also increases. So this is first type of solid where dissolution process is endothermic. So according to Le Chatelier principle, as temperature increases, solubility also increases. So example of such solid is say KCl, KNO3, NH4Cl, HgNO3, etc. So these are example of solids where dissolution process is endothermic. So as temperature increases, solubility of such solid also increases. Next we consider second type of solids. As temperature increases, solubility decreases. As temperature increases, solubility decreases. So there are few numbers of solids where this behavior is obtained. As temperature increases, solubility decreases. So in this case, if we draw graph between solubility and temperature, so this is nature of the graph. So as temperature increases, solubility decreases. As temperature increases, solubility decreases. In previous case, as temperature increases, solubility also increases, because in previous case, dissolution process is endothermic. So according to Le Chatelier principle, as temperature increases, solubility increases. But here, solubility decreases because dissolution process is exothermic. So here, solute plus solvent. So solution and dissolution process is negative, it is exothermic. So those solids where dissolution process is endothermic, so exothermic, such cases as temperature increases, solubility decreases. But there are very few numbers of such solids. For example, say lithium sulfate, cerium sulfate. So this type of solids shows this type of behavior. Because, for example, say lithium sulfate, when treated in water, so lithium positive aqueous and SO4 dinegative aqueous, and in this process del H value is negative, that is exothermic. So for those cases where dissolution process is negative, that is exothermic, so in such cases solubility decreases with increasing temperature. So there are few examples of such solids: lithium sulfate, cerium sulfate, etc. And next consider third type of solids. So in first two cases there is regular behavior. Regular behavior means first case is solubility always increasing. Solubility always increasing. Second case solubility always decreasing. So this is called regular behavior. In third cases there is irregular behavior. Now what is irregular behavior? Irregular behavior means if we plot a graph between solubility and temperature, then first increases to a certain extent and then decreases with rising temperature. So first increase and then decrease. So this is called irregular behavior. So first two cases there is regular behavior. First case where always increasing because process is endothermic. Second case where always decreasing because process is exothermic. And in third case there is irregular behavior, means first increases to a certain extent or up to a certain temperature and then decreases with increasing temperature. So example of such solid is sodium sulfate dot 10 water. Sodium sulfate dot 10 water. So in sodium sulfate dot 10 water, when treated in water, so increasing temperature, solubility of this solid increases and this process is continue up to 32.8 degrees centigrade. So this process is continue up to 32.8 degrees centigrade, and on further increasing temperature the solubility decreases. Now this temperature 32.8 degrees centigrade, where nature of dissolution changes, so this temperature is called transition temperature. So what is transition temperature? Transition temperature means such a temperature where behavior of solid changes from increasing to decreasing. So in sodium sulfate dot 10 water, this temperature is 32.8 degrees centigrade. Now what is the explanation behind such a irregular type of dissolution? So when sodium sulfate dot 10 water is treated in water, and as temperature increases, solubility increases. When temperature reaches at 32.8 degrees centigrade, it reaches 10 water. It loses 10 water. It loses 10 water and becomes anhydrous. So this form is up to 32.8 degrees centigrade. It is hydrated form. And above 32.8 degrees centigrade, it becomes anhydrous. This is hydrated form. It is with water. So up to 32.8 degrees centigrade, sodium sulfate with 10 water in hydrated form, and above 32.8 degrees centigrade, it loses its 10 water and becomes anhydrous. So hydrated form where process of dissolution is endothermic. So in this form, process of dissolution is endothermic. That is, del H is positive. And in this form, process of dissolution is exothermic. That is, del H is negative. So if we explain this irregular behavior by taking example of sodium sulfate dot 10 water. So sodium sulfate dot 10 water is a hydrated salt, and this salt when treated in water, so up to 32.8 degrees centigrade, process of dissolution is endothermic. So as temperature increases, solubility increases. On further increasing temperature, that is above 32.8 degrees centigrade, it loses its 10 water and becomes anhydrous. And dissolution of anhydrous sodium sulfate is a exothermic process. So decreases with increasing temperature. So on the basis of temperature effect, solids are of three types. Most of the solids where dissolution process is endothermic. So as temperature increases, solubility increases. For few numbers of solids where dissolution process is exothermic, for such solids as temperature increases, solubility decreases. And very few numbers of solids where irregular behavior is observed, that is up to certain temperature dissolution process is endothermic, so solubility increases with increasing temperature, and beyond this temperature dissolution process is exothermic, so as temperature increases, solubility decreases. So this is all about temperature effect. And now we consider last one, which is pressure effect. Effect of pressure. Effect of pressure. Now what is the effect of pressure? Actually here solid and liquid. So two components are incompressible. That is, there is no effect of pressure on solid or there is no effect of pressure on liquid. So there is not much effect of dissolution of solid in liquid. So very little effect of pressure on dissolution of solid in liquid. What is the reason? Because both solid and liquid are incompressible. That is, on applying pressure, there is hardly any change in volume of solid or liquid. So there is no effect or there are almost nil effect of pressure on dissolution of solid in liquid. So if we sum up solubility of solid in liquid, first of all, what is solubility of solid in liquid? Solubility is defined as amount of solid or solute required to saturate 100 gram of solvent at a particular temperature. Now solubility of solid in liquid depends on nature of solid, nature of liquid, temperature, and also very little effect of pressure. If we consider effect of or nature of solid and liquid, then solids are of two types, polar or ionic and non-polar. Liquid also two types, polar and non-polar. So here basic principle is like dissolve like. So polar or ionic solid dissolves in polar solvent and non-polar or covalent solid dissolve in non-polar solvent. Reverse is not possible. So this is first point. And on the basis of temperature, solids are of three types, where dissolution process is endothermic, so solubility increases with increasing temperature. Where dissolution process is exothermic, so solubility decreases with increasing temperature. And third one, there is irregular behavior, that is solubility first increases to a certain extent and then decreases with increasing pressure. And there is little effect of solubility of solid and liquid on pressure. So next we consider solubility of gas in liquid. So solubility of gas in liquid. Gas in liquid means, say, carbon dioxide is a gas, water is a liquid, say ammonia is a gas, water is liquid, say oxygen is gas, water is liquid. So all three are example of gas in liquid, gas in liquid, gas in liquid. Now, solubility of gas in liquid, like solubility of solid in liquid, depends on four factors. Number one, nature of gas, nature of liquid. Number three, very important, effect of pressure and also effect of temperature. So solubility of gas in liquid depends on nature of gas, nature of liquid, temperature and pressure. So in previous case there is not much effect of pressure, but here since it is gas, so there is much effect of pressure. So effect of pressure is very important. So solubility of gas in liquid depends on nature of gas, that is solute, and nature of liquid, that is solvent. Second one, temperature, and third one, pressure. So first we consider nature of gas and nature of liquid. So gases are classified into two types. For some gases which are easily liquefied and there is chemical reaction with solvent, are highly soluble in solvent. For example, so first category gas is carbon dioxide, ammonia, sulfur dioxide, HCl, etc. So these are incompressible gas. That is, gases can be liquefied while lowering temperature and increasing pressure. So this is one category of gas. And second category, hydrogen, helium, nitrogen, oxygen. These are permanent gas. So these are difficult to liquefy by lowering temperature and increasing pressure. So gases are classified into two types. Some gases where liquefaction is possible easily by lowering temperature and increasing pressure. And some gases where liquefaction is very difficult. So first type of gas is easily soluble in solvent like water because there is chemical combination with solvent. So first we consider nature of gas and nature of solvent or liquid. Say carbon dioxide, sulfur dioxide, ammonia, etc. are easily soluble in water. This is because of chemical combination with water. Chemical combination with water. So these gases are highly soluble in water. So those gases which are easily liquefied by lowering temperature and increasing pressure, and there is chemical combination with solvent, such gases are highly soluble in water. And some gases, hydrogen, helium, nitrogen, oxygen, etc., where there is no combination with solvent, no reaction with solvent, so such gases are less soluble in water. So gases are classified in two categories. Some gases where chemical combination takes place with the solvent are highly soluble in water, and these gases are easily liquefied by lowering temperature and increasing pressure. And some other gases where liquefaction is not possible, or in other words, these are incompressible. So such gases where there is no chemical combination with the solvent, so these are less soluble in water. So these are two types of gases. Chemical combination takes place, highly soluble in water. No chemical combination with solvent or water, so less soluble in water. So these are two types of gas where depends on nature of gas and also nature of liquid. Second factor is called temperature. So our second factor is temperature. So almost all gases where dissolution process is endothermic, here dissolution process is endothermic, it is positive. So almost all gases, as temperature increases, solubility decreases. This is because dissolution process is exothermic. Sorry. So as temperature increases, solubility decreases. So there is important question in our exam: why solubility of gases decreases with increasing temperature? Why solubility of gas decreases with increasing temperature? This is because dissolution process is exothermic. So according to Le principle, solubility decreases with increasing temperature. So first factor, nature of gas, and second factor, nature of gas and solvent, and second factor, temperature. So first factor, gases are classified into two types. Some gases where chemical combination takes place, or gases which are easily liquefied are highly soluble in water. Those gases which there is no chemical reaction with water or solvent, so these are less soluble in the solvent. And second factor is temperature. Generally dissolution process is exothermic, so as temperature increases, solubility decreases. So in next class I will discuss effect of pressure, because effect of pressure is very, very important. Okay, thank you.